Okay, so get this. We're diving into something today that's, well, it's pretty fundamental to the future of the internet. A&D, kind of mind-bending at the same time.
Sounds intriguing.
Work verification, but hold on with a quantum twist.
Ooh, quantum. Okay, I'm listening.
Yeah. So basically the question is, can quantum computing actually solve the network verification challenges we're going to be facing in the future?
Ah, I see where we're going with this.
Exactly. And we're basing this whole deep dive on some really fascinating new research.
Hmm. Yeah, that's a question with huge implications, actually. As
Right.
networks get more and more complex, verifying they're actually working correctly, it just becomes exponentially harder.
Yeah, for sure.
We're talking about systems so intricate that, like, traditional methods, they might take centuries to analyze.
Centuries. Oh, wow. That's definitely not what we want for a healthy internet. So, okay, so this research paper, it's called Toward Applying Quantum Computing to Network Verification. It's from Hotnets 24 by Dozier and team, and they're suggesting that, well, that we might have a solution hidden in those tiny particles that make up the quantum world.
Yeah, that's the idea they're exploring.
Wow.
How the unique capabilities of quantum computing, namely its potential for massive speedups and certain types of calculations, how that could completely revolutionize how we verify networks.
Okay, so we're not just talking about like making sure cat videos stream smoothly, right?
No, definitely not.
Good.
Network verification, or NWV for short, it's about ensuring the reliability and the security of the entire internet.
The entire internet.
Think of it as a checkup for the internet's infrastructure,
Uh,
making sure data flows correctly and securely, from like financial transactions all the way to critical communications and everything in between.
okay, got it. Yeah, that makes sense. So this paper, it dives into two main types of NWV, right? Data plane and control plane.
That's right.
Can you give us a quick breakdown of what those are?
Okay, so imagine the internet as a vast highway system.
Okay, I can picture that.
All right, so the data plane is all the traffic flowing on those highways.
Uh-huh.
The data packets traveling between different points.
Okay.
And data plane verification, well, it checks if this traffic is following the rules of the road, taking the correct routes, and if it's arriving safely at its destination.
So it's like making sure the data packets don't get lost or take a detour through some like digital back alley.
Uh-huh, exactly.
Okay, makes sense. What about the control plane then?
So think of the control plane as like the traffic management system.
Okay.
The signs, the signals, the protocols, all those things that govern the flow of data. Control plane verification, well, that's about ensuring this brain of the network, that it's actually functioning properly,
Right.
making efficient routing decisions and being able to adapt to any disruptions like network failures and stuff.
So it's like making sure the internet's traffic lights are all in sync and there are no like digital pileups.
Exactly, you got it.
Okay, cool. But how exactly does quantum computing offer an advantage here? Like what makes it so special for NWV?
So this is where things get really interesting.
All right, lay it on me.
Quantum computers, they have the potential to provide what we call a quadratic speedup for certain NWV problems.
Quadratic speed up. Wow, that sounds impressive. But I think our listeners could use a real world example to really grasp what that means.
Of course, yeah. Imagine you're searching for a specific book in a library, but this library has millions of volumes.
Millions. Oh wow.
Yeah, so a classical computer, what it would have to do is check each book one by one, which could take ages, right?
Yeah, definitely.
A quantum computer, though, well, thanks to the principles of superposition and entanglement, it can explore multiple possibilities simultaneously, so it's like checking multiple books at once.
Oh wow, that's incredible. So it's like having a superpower for searching, finding that needle in the haystack
Hmm.
in a fraction of the time.
Precisely.
Amazing.
And the speed boost, it's largely due to a quantum algorithm called Grover's algorithm.
Grover's algorithm. Okay, I'm adding that to my list of quantum buzzwords
Haha, yeah, it's a good one to know.
for sure. So, did the researchers actually put this idea to the test? Did they run these quantum NWV algorithms on an actual quantum computer?
They did. They tested their approach on a simplified network,
Okay.
both through simulations and using IBM's Osaka.
Oh, the Osaka.
Yeah, it's a 127 qubit quantum computer.
Wow, a 127 qubit machine. That sounds pretty cutting edge.
It is, yeah, one of the most advanced out there.
So what did they find? Were they able to verify the network using these quantum algorithms?
Well, the results were definitely promising.
Yeah.
They showed that quantum computing could indeed be applied to NWV problems, offering significant speedups in some cases.
That's great.
But it is important to note that we are still in the early stages of this research.
Right. So it's like the Wright brothers' first flight. We've proven that it's possible, but there's a long way to go before we have like quantum jumbo jets for network verification.
Exactly. Haha, that's a great analogy.
So there's a lot more research and development needed before we see quantum computers become a standard tool for NWV.
Yes, definitely.
Well, I'm already intrigued. So how did they actually translate these complex network problems into something that a quantum computer can understand?
Okay, so for the data plane verification, they used a technique called header space analysis.
Header space analysis.
Yeah, so imagine dividing all the cars on a highway into groups based on, certain characteristics like their make or model.
Okay.
Header space analysis does something similar with data packets.
Uh,
It groups them based on specific features in their headers.
so instead of analyzing each packet individually, the quantum computer can work with these larger groups, making the whole verification process more efficient. Exactly.
Smart. And what about for the control plane? How do they handle that?
For the control plane, they use a method called NetDice,
Net dice. Okay.
which essentially simulates different network disruptions like link failures to see how the network responds.
So they're finding clever ways to represent these complex network problems in a language that a quantum computer can process.
Yeah, that's a good way to put it.
But this all sounds very promising.
It is.
Are there any challenges or limitations that we need to consider?
Oh, there are definitely some hurdles to overcome.
Like what?
One of the biggest is scalability.
Scalability. Okay.
Yeah, the examples in the paper, they use, simplified networks,
Right.
but real-world networks, they are vastly more complex.
Oh, yeah, for sure.
Scaling these quantum algorithms to handle the sheer size and interconnectedness of the internet, I mean, that's a major challenge.
So it's like we figured out how to build a model airplane, but we need to figure out how to scale that up to a jumbo jet.
Yeah, pretty much.
That seems like a pretty significant leap.
It is. And it's not just about having more powerful quantum computers with more qubits,
Right.
although that's certainly part of the equation.
Sure.
We also need more sophisticated algorithms,
Okay.
ones that can efficiently represent these complex networks in a way that quantum computers can actually work with.
So it's a two-pronged challenge, better hardware and better software, essentially.
Exactly.
We need to advance both the capabilities of quantum computers and our understanding of how to translate these network problems into, a quantum language.
Yeah, we need both for sure.
Okay, speaking of understanding, the paper also mentions that quantum computers are still, quite noisy. What does that mean exactly? Is it like static on a phone line, interfering with the calculations?
It's a bit more complex than that.
Okay,
Quantum computers are incredibly sensitive to their environment,
I see.
and even the slightest disturbance can introduce errors into their computations.
Wow, really? Yeah, it's like trying to perform, a delicate surgery,
Okay.
but on a rocking boat.
Oh, I see.
The slightest tremor can throw everything off.
Oh, wow. So these errors, this noise, it can potentially skew the results of the verification process.
Yes, and that's a major hurdle for practical applications.
Right.
Researchers are actively working on developing error correction techniques to, try to mitigate this noise. But it's a complex problem that requires some ingenious solutions.
It sounds like we need to find a way to create a more Zen-like environment for these quantum computers.
Aha, I like that.
Like a calm and stable space where they can do their work without being disrupted by the chaos of the outside world.
That's a great analogy. And yeah, creating more stable and reliable quantum systems.
Right.
That's a key area of focus in the field right now.
For sure, but noise isn't the only challenge, is it?
No, it's not.
We also need to figure out how to integrate these quantum computers into existing network infrastructure.
Right, because we can't just swap out our Wi-Fi routers for quantum computers.
Yeah, not yet at least.
Exactly. So how do we bridge that gap?
Yeah, how do we bridge that gap between the theoretical potential of quantum NWV and the practical realities of today's internet?
It's a question of engineering and innovation.
Okay.
Quantum computers are still, relatively bulky, and they require specialized environments to operate. Integrating them into the existing internet infrastructure, well, it's going to require creative solutions
For sure.
and likely involve a a gradual transition over time.
So we're talking about like a hybrid approach, perhaps,
Yeah, that's probably what we'll see.
where quantum computers work in conjunction with classical systems to handle specific verification tasks.
Exactly. It's likely we'll see a phased integration
Okay.
where quantum computers are used for, the most challenging verification problems,
Right.
while classical systems handle the rest, but who knows what the future holds, right?
Yeah.
Perhaps one day we'll have like quantum chips embedded in our devices,
Wow.
allowing us to tap into the power of quantum computing for, everyday tasks.
Now that's a thought-provoking image. It makes you wonder if we're like on the verge of a quantum internet revolution.
A quantum internet revolution.
Yeah, where the very foundation of the internet
Yeah.
is transformed by these mind-bending technologies.
That'd be something.
But revolutions often come with their own set of challenges, don't they?
Absolutely. And one of the most significant challenges we need to address
Uh-huh.
is the potential impact of quantum computing on, internet security.
Right.
As we've discussed, quantum computers have the potential to crack many of the encryption algorithms that protect our online data today.
Oh, that sounds like a recipe for cyber chaos. What can we do to prevent that?
Mm.
Are we just sitting ducks waiting for the quantum hackers to arrive?
Not necessarily.
Okay.
Thankfully, researchers are already hard at work developing quantum-resistant cryptography.
Quantum-resistant cryptography.
Yeah, so new encryption methods that are specifically designed to withstand even the most powerful quantum computers.
Oh, wow.
It's like building a digital fortress with walls strong enough to repel any quantum attack.
So it's a race against time.
It is.
Can we develop these quantum defenses before malicious actors figure out how to exploit the power of quantum computing for, nefarious purposes?
It's a challenge we need to take seriously for sure.
Yeah, definitely.
But the potential rewards of a quantum internet, they're immense.
Like what?
Imagine a world where scientific breakthroughs are accelerated by, quantum simulations, where global communication is instantaneous and ultra secure,
Wow.
where the boundaries of human knowledge are expanded by the sheer power of quantum computation.
It's both, like exhilarating
Right.
and a little daunting to contemplate the possibilities.
Well, yeah.
But it underscores the importance of having these conversations now.
Yes.
Before the quantum revolution is fully upon us.
We need to be prepared.
We need to be prepared for both the challenges and the opportunities that lie ahead.
I couldn't agree more. And that's why research like this,
Uh-huh.
exploring the potential of quantum computing for network verification, it's so critical.
Right.
It's not just about solving, technical problems,
Okay.
but about shaping the future of the internet in a way that benefits all of humanity.
Well said. As we've been discussing this,
Yeah.
one thing that struck me about the paper
Uh-huh.
is the way these quantum algorithms are essentially searching for, errors or violations in the network.
Okay.
They're playing the role of a quantum detective,
I like that.
sniffing out any signs of like network misbehavior.
That's a great analogy. And it raises a fascinating question.
Oh,
Could we use this same approach to proactively identify and prevent network problems before they even occur?
interesting.
Instead of simply reacting to errors, could we leverage quantum computing to anticipate and mitigate them?
Now that's a mind-blowing concept.
It is, isn't it?
It's like having a quantum crystal ball
Yeah.
that can predict network glitches before they happen, allowing us to maintain a smooth and uninterrupted flow of information.
It's certainly a tantalizing possibility.
For sure.
Perhaps quantum computing will enable us to create like self-healing networks
So healing networks, wow.
that can adapt and optimize themselves in real time,
Okay.
ensuring a seamless and resilient internet experience for everyone.
It sounds like science fiction.
It does, doesn't it?
But then again, so did many of the technologies we take for granted today.
Yeah, it's true.
Who knows what the future holds? Perhaps one day we'll look back on this research as the first step towards a truly intelligent and self-aware internet.
It's an exciting prospect, and
Yeah.
it highlights the fact that we're just beginning to scratch the surface of what quantum computing can do for networks.
Yeah.
We've only dipped our toes into the vast ocean of possibilities, and there's a whole world of exploration and discovery ahead of us.
And who knows what wonders we might find beneath the surface.
Exactly, who knows?
It's an incredible time to be alive, to witness the birth of these transformative technologies, and to contemplate the profound impact they might have on our lives.
Couldn't agree more. It's a time of both, great challenge and immense opportunity.
Yeah.
And it's up to us to navigate this uncharted territory with wisdom, with foresight, and a sense of shared responsibility.
Beautifully said. But before we get lost in a sea of quantum speculation,
Oh,
I
great.
think it's
Okay.
time to bring this deep dive to a close. We've covered a lot of ground today,
We have.
from the nuts and bolts of network verification to like the mind-bending potential of quantum computing.
It's been quite a journey.
It has. Before we wrap up, though,
Yeah.
I'd love to leave our listener with something to ponder,
Okay.
a question that kind of builds on what we've discussed.
I like where you're going with this.
What if, instead of just verifying existing networks,
Ah.
quantum computing could actually be used to design entirely new types of networks?
Oh, wow.
Networks that operate on the principles of quantum mechanics,
Okay.
leveraging entanglement and superposition
Right.
to achieve levels of speed, security, and efficiency that are just unimaginable with classical networks.
Now that's a truly fascinating concept.
Right.
A quantum internet
Go quantum internet.
that operates on an entirely different set of rules.
Yeah.
Where data can be in multiple places at once
Wow.
and communication is instantaneous.
It's a vision that stretches the boundaries of our current understanding of what a network can even be.
It really does.
Imagine a world where quantum networks connect not just computers,
Okay.
but also like sensors, scientific instruments,
Uh-huh.
and even human brains,
Wow.
creating a global network of intelligence and collaboration on an unprecedented scale.
That's incredible to think about.
The implications for scientific discovery, technological innovation,
Right.
and even our understanding of consciousness,
Yeah.
they're staggering.
It's a vision that both inspires and challenges our imagination.
It does.
It makes you realize that this deep dive into quantum network verification,
Yeah.
it's just a glimpse into a much larger and more profound transformation
Right.
that might be on the horizon.
We've only just begun to explore the potential of quantum computing for networks.
That's true.
And the journey ahead, it's filled with both exciting possibilities and complex challenges.
It's going to be quite a ride.
It's a journey that will require collaboration across disciplines,
Yeah.
from computer science and physics to ethics and philosophy.
It's a multifaceted challenge.
So to our listener, we encourage you to delve deeper into this fascinating field.
Yeah, learn more.
Check out the full research paper by Dozier and his team if you want to, explore the technical details.
It's a good read.
And most importantly, keep those quantum questions coming.
Yes, keep asking questions.
Who knows? Your curiosity might spark the next breakthrough in quantum networking.
You never know.
The future of the internet, it's being written right now.
It is.
And it's a future where quantum technologies,
Right.
they will undoubtedly play a defining role.
A defining role.
It's a future filled with possibilities that we can only begin to imagine.
It's an exciting time to be alive.
It is. And on that note, we'll sign off for today.
Thanks for listening, everyone.
Thanks for joining us on this deep dive into the world of quantum network verification.
It's been a pleasure.
Until next time, keep exploring, keep questioning,
And keep learning.
and keep diving deep into the mysteries of our increasingly quantum world.